What is concavity? Concave up is if you have a function that is a U-shape. Concave down is if you have a function that's an upside down U-shape. We would say this here is concave down, and we would say this right here is concave up. So, skipping that part here, if f is concave up, then f prime is increasing. If f is concave down, then f prime is decreasing. F double prime greater than 0 means f is concave up. If f double prime is less than 0 means f is concave down. So keep in mind, for a function to be concave up, you can say either the first derivative is increasing or the second derivative is positive. Be very careful. Increasing and positive are two different terms here. Similarly, for concave down, you can say the first derivative is decreasing or the second derivative is negative. If we look at this graph right here, f of x is equal to sine x. See this U shape here? So we know that the second derivative is positive, greater than 0, because it's concave up. Right here you can see it's concave down, so the second derivative is negative, less than 0. Similarly here again, that's concave up. Second derivative is greater than 0. It's concave down. F double prime is less than 0. So, 1. Find the intervals of concavity for f of x is equal to all this right here. If you want to find the intervals for concavity, from this you should just find the second derivative. So the first derivative f prime of x is equal to, let's see, x cubed minus 12x plus 1. And then we find the second derivative. F double prime of x is equal to 3x squared minus 12. Set that equal to 0. And then that's 3x squared is equal to 12. And then x squared is equal to 4. And x is equal to plus or minus 2. The next thing you want to do is draw your tables. So here's a table, you set it up with your plus and minus 2 over here, and you draw the intervals before, in the middle, and after. So negative infinity to negative 2 here, then when it's negative 2 it's 0, and do negative 2 to 2, 2 to infinity. So this is where you just plug in a number here into the second derivative to see if we get a positive or negative value. So pick a number between negative infinity and negative 2. Let's say it's negative 100. If you plug x is equal to negative 100 into f double prime, you'll get a positive answer. So that's positive. Between negative 2 and 2, let's pick 0. 3 times 0 squared is 0, minus 12, that's a negative answer. 2 to infinity, let's pick 100. Plug it into x, we get a positive result. So, f double prime, when it's positive, means we have a concave up function. So we can say concave up on negative infinity to negative 2 and 2 comma infinity. Let's say because f double prime is greater than 0. That's a B slash C, short for because f double prime is greater than 0. We can now say concave down on negative 2 to 2 because f double prime here is less than 0. You can see here This interval here, f double prime, is less than 0, so that's concave down. So, a point of inflection. There is a point of inflection of f at x is equal to c if f of c is defined and f double prime changes signs at x is equal to c. In other words, a point of inflection is where the graph changes concavity. Changes concavity. So for example, if I have a graph that was concave up and then concave down like that, you can see like the point exactly where it changes concavity might be somewhere in the middle right here. This is what we would call the point of inflection because it's changing from concave up to concave down. But it can also change from concave up to concave down as well. Sorry, let me just do another example of it starting concave down, concave up. You can see it's changing concavity, both of these graphs here. So if we go back to our graph here, right, above from sine x, we can see that there are a few different points of inflection. You see here is the point where the graph changes from concave up to concave down, right here, 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 here. We can say points, we can say inflection points. These blue dots here are all inflection points because they change concavity at these points. For this question one we just did where we found the intervals of concavity, just as an extension, we can say that you see at -2, the function goes from concave up to concave down. So we can write points of inflection at x is equal to 2 because x is equal to -2 and x is equal to +2 because f double prime changes sign. This is f double prime. F double prime changes sign at both points. All right, there's two common mistakes when finding a point of inflection. First of all, mistake number one, assuming that because f double prime is equal to 0 means that there's a point of inflection. When f double prime is 0, you could have a point of inflection as it's a candidate, but you're not guaranteed a reflection. Also, common mistake number two, assuming that when f double prime does not equal 0, there is no point of inflection. When I say do not equal 0, I could mean that f double prime is DNE at a specific point. So a graph to showcase that one is, let's say we have a concave up function, but then there's a sharp curve here that goes to concave down. Right here at this point, there's no derivative. The derivative does not exist here because this is a sharp corner, but you're going from concave up to concave down. So it's still point of inflection, even though f double prime is not 0 and, well, in fact, it's DNE. Question 2 and 3 here are very common kind of questions they might ask you on the AP exam. Actually, they will ask you questions like these. These come up every single year. So given the graph of f prime, so see question 2 is f prime, find the points of inflection, state the intervals of concavity. So remember, for concave down, f prime has to be f prime has to be decreasing. Yeah, for concave down, f prime should be decreasing. So concave down. We're just looking at when the f prime graph is decreasing. You see it's from -4 to -1. So here we have concave down. And then also from 1 to 2, we have f prime decreasing, so it's concave down. Remember, decreasing and negative are two different things. You'll see later in question 3. But concave up is when f prime is increasing. So you see from -1 to 1, f prime is increasing, and from 2 to 3, f prime is increasing right there. So for the points of inflection, on the PT point of inflection, we just have to know where is the graph changing concavity. So at x is equal to -1, you see at this point right here, we're going from concave down to concave up. Right here, we are going from concave up to concave down. So x is equal to 1. And right here, at x is equal to 2, we're going from concave down to concave up. Again, this is just with the f prime graph. Again, for f prime to determine concavity, you're looking at when f prime is increasing and decreasing. But for question 3, points of inflection, if we're given the second derivative graph, we're simply looking where is the graph, so if we're trying to find concave down, where is this graph negative, below 0? So this is our imaginary line, right? Or not our imaginary line, the x-axis. Anything above is positive, anything below is negative. So to find where this function is concave down, you just look at where the f double prime graph is below the x-axis. So concave down, -3 to 1, and 3 to, well, 3 to infinity, because it's 3 and the arrow keeps going, so it's 3 to infinity. Concave up, we're just looking for where is this graph above 0. So you see it's all the way from the left, -infinity to 3. Sorry, -infinity to -3, and then 1 to 3. Let's see, very minor things. So you see how we didn't have any -infinity or +infinity in question 2? That's because there were no arrows on the left and right. But in question 3, we have these arrows that mean the graph goes on forever. So points of inflection, again, is where the graph changes concavity. So at -3, f double prime goes from positive to negative, changing concavity. When x is equal to 1, that's another change in concavity. F double prime goes from negative to positive, and then at 3, f double prime goes from positive to negative. So does the line tangent to the graph f of x equals x e to the negative x at x equals 1 lie above or below the graph of f, and why? So you need to think about this. If you have a concave up function and you have a tangent line at a point, you see how the tangent line is going to be below the curve? That's an underestimate. That's an underestimate. If you have a concave down function, any tangent line is going to be above, which would be an overestimate. So what we want to do here is find what is the, no, we have to find at +1, is the second derivative positive or negative? That'll determine whether we have an underestimate if the second derivative is positive, or an overestimate because the second derivative is negative, less than 0. So we can just find these derivatives. F prime of x is equal to 1 e to the negative x. This is just a product rule. and chain rule question. Equals e to the negative x minus x e to the negative x. And the second derivative is just e to the negative x, parentheses -1, minus e to the negative x minus xe to the negative x. And then if you put this in the calculator, f double prime of 1, you plug 1 to all this, you'll find that you get a -1 over e, and that will actually be less than 0. So our second derivative is negative. So does the line tangent of the graph lie above or below the graph of f? It's going to be above, because f double prime of 1 is less than 0. This here is a very important lesson. You'll see questions like this every single year on the AP exam. If you have questions, please ask your teacher for help.